My name's Steve Cato. I'm business development with Taggle, and on the panel we have a panel here, panel of two and an admin is Amal de Silva. Hello, Amal.
Hi guys.
Amal's account manager, and probably a lot of you know Amal from interacting with him on our existing systems, as most people here I think are existing customers. So I hope that you've, just from an admin perspective, I hope you understand where your safety exits are out of the house, just in case. We can't guide you to that because it's all a bit individual these days. We've got everyone on mute, only because otherwise background noise kills things. So that is, that's that. The topic of today's talk is installation guide for optimal RF performance. And the idea is that we're just going to go through some of the things that we've learned, some of the things that we learned to do well through the experience that Taggle have had over the years, the last 10 years installing systems. So introduction, webinar admin. There's a Q&A button for questions, so please feel free to ask any questions in there. If we don't get to questions, we will capture them and respond to them afterwards in writing. And as I say, the thing's being recorded, so we can look back at that as well. We have some upcoming webinars, the first Wednesday of each month at 3. On the 2nd of September, Simon Igloy from Townsville City Council is going to present investigating pressure. Townsville have done a lot of work around that and using our Aqualis sewer product to visualize what they're doing. So that'll be interesting. And then Siobhan on the 7th of October is going to talk about customer communications. Siobhan's our marketing manager, and she is there not just to help set up webinars, as she's done here, thank you Siobhan, but also to help customers with communication examples, editing and producing good news articles and those sorts of things. So she's a resource that I urge you to draw on. Very briefly, because most of you will know this, this is our technology overview. On the left-hand side, we have the field, what we're talking about today, and we've got lots and lots of different types of sensors out there. Now, most of what we deal with, not all, but most of what we deal with is water meters. All of them, of course, we put a radio tag on. And so we're talking about radio communications, getting that signal back to our receivers, which sit in the, so I'm just going to change something here. Oh. On our receivers, which, there we go, laser pointer, look at that, which sit up generally on your assets, receiving all those signals from water meters and other data. So today's talk is going to focus around this piece, which is making sure that those signals get back to the receivers so that you can use the data. And it's not always an easy trick. One of Taggle's goals, one of our aims and promises is to provide 100% connectivity. So we don't believe that a system that says, oh, you know, we can't get those last 5%, you'll just have to live with not being able to read those and go out and read them manually. We don't think that's good enough. So we aim to get 100% of those meters back, and there's various things that we do to help you do that, but that's our job to do it when we roll out a system. Every one of those, every one of the buildings and parks, etc., in here has a Taggle device on it, and each one of them is feeding data back to the council. So installation comes down to some pretty straightforward things. So selecting the right type of tag for the environment. So we've got a couple of different types of tag, ensuring that they're placed in the right position. And most importantly, during install, is doing a reception survey for each installation. And you can see here, this is our Aqualis field app on a tablet, taking a geo map of where that tag and meter is to feed back into Aqualis water software. So Amal is going to, oh no, in a second, Amal's going to talk about some things. But first of all, so where does the signal come from? Well, the signal comes from the antenna on the tag, and we thought it would be useful to just make sure everybody knew where the antennas are. So these little orange bars are a representation of where the antenna is in our tags. This is our ADC, a 25 milliwatt tag. And this is the HP high power 500 milliwatt tag. You might have seen some recent LinkedIn articles where George is up on the Queensland coast playing around doing some reception surveys, a lot of which he's only doing just for fun. But we had one of these going 88 kilometres up there, including over the top of a mountain. So you can get some pretty good range. In our two types of integrated Taggle radio meters, which is the Honeywell V200 HT and the 20 and 25 mil, and the Akiba magflow meter in 20 millimeter, both of those have a different shaped antenna, but sitting at the top or near the register on those meters. So it has a different signature, and I'll show that to you in a minute. Coming up soon, our Rosella and Parakeet and the lorikeet, which will replace the ADCs and the HPs. Still with the Byron radio, still with the antenna in pretty much the same spot, but with a lot more smarts on board. So when we get to release those, we'll go over what they will do in addition to what the ADCs and HPs currently do. Exciting times coming. So how do the radio waves come off the antenna? Speaking to one of our in-house experts, Mr. Kenny, he said you can think about it like a lightsaber. And I thought, oh, that's a nice thing. So with a lightsaber, the light doesn't come off the tip; it comes off the sides. So the tip is actually a null point, and the radio waves radiate out from the sides of the antenna. Radio waves bounce off things, so you know, your crystal sets used to bounce off. If anyone is as old as me and knows about crystal sets, used to bounce off the atmosphere, so you could listen around the world. Well, Taggle's Byron radio is particularly bouncy, which make it very well suited to what we do. Bouncy radio means that it can bounce off hard surfaces around about the place and make its way to the receiver, even if it can't particularly see it directly line of sight. And radio waves are absorbed by materials next to them. So things like metal and water absorb lots and lots of the energy, and we're talking about low energy devices here, 25 milliwatts for our low power tags and 500 milliwatts for our high power tags. Your mobile phones is 1 watt, so we're not even as powerful as a mobile phone. So we've got to make the most of it. So we want to avoid things like metal and water. Some things like plastics and timber absorb very little, although wet timber and wet plastics perhaps are not so good. So this is a better representation of how the radio propagates from the antenna. And with the ADC and HP and the lorikeets, parakeets, etc. later on, the radio waves come out around the tip of the antenna like that, and the red is higher power. And as you can see up towards the null spot, there's less power emitted there. So if you want to get maximum range, you don't want to point the tip towards your receiver because you've actually got your lowest amount of power coming from there. You want the sides of that tag pointing towards the receiver. Obviously, with any tag like that, if your receiver is over here, then it's only going to see the radio that is bouncing that way. It's not necessarily going to see anything on that side. So you've sort of got a maximum of 50% of your power that you can possibly see. With the integrated meters, the V200HT and the Akibas, it's a different shaped antenna, and so the propagation is different as well. They're organised so that the majority of the power is coming up out of the top of the meter. And obviously that's the best position to have this, so that we maximise the amount of energy that is coming out to go towards the receiver. So that's how they work. And now Amal's going to talk a little bit about checking the signal strength on every install, which is something that's needed to be done.
Yeah, so most of our customers, installers, have been trained up in the Taggle survey page, which has been around for about 12 months now. Our older customers were used to a different one. And using that tool and using the magnet swipe on our devices, or an NFC tap on our newer devices, you can force a transmission, which will then go through our network and be available to you on your phone, so you can tell live as you're about to commission a device if it's going to work in situ before you walk away from it. So we'll just go through a quick video of how that survey page works. So there's two parts of the survey page. I'm going to go through the test tab first.
Yeah.
So yep, so you start monitoring. If in the video now, Bhargav is going to click on test, and he's got tag ID 502929 with him. So he's going to put that in here and hit listen. And then he's going to hold the device where he's going to install it and swipe it with a magnet. So each device has its own spot where you can swipe it. As you can see, it'll tell you if it's okay. And you should see 5 transmissions come through, which are shown as these 5 dots here. So because it gives you a burst of 5 transmissions when you swipe it with a magnet, or when you do the NFC tap if it's a V200 HT. And that the green box down the bottom tells you, okay, yep, that's commissionable. Or if it's coming in at a weak signal strength, it'll tell you try and raise it higher or use a higher powered device. And then the signal strengths are demonstrated on the little bar on the right hand side there. Most of our customers, because our receivers are so sensitive, will see down past below -130. So anything up until -130 is commissionable. There's some customers where there's extra interference, where those numbers change a little bit. But as a rule of thumb, -130 is where we ask you to go down to. Thanks, Steve. So the next tab in the same survey tool is the monitor tool. So if you hit the monitor button at the top there, it'll show you all transmissions coming in on your particular network. So if I was in Sydney, anything on the Sydney network will come down here. I can use the buttons at the bottom to ignore certain tags and watch a particular tag. So now we're going to watch the tag that we want to watch, which is 502929. And after I've swiped them in the magnet now, I can see all the receivers that it's coming in on. So it's okay to be heard on multiple receivers where we have a lot of redundancy in networks. And that's shown in the second column there. And then as you move across about halfway through, there's an RSSI column, and that's your signal strength. Again, anything up until about -130 is okay. And if you're hearing on multiple receivers, then you're looking for the one that's doing the best, because obviously that's the one that you want to be heard on. So if, it might be booming in this case, it's coming in at -85 on receiver 525, that's booming in, and we're hearing, obviously this is in Sydney, so we're hearing a lot of receptions everywhere. Yep, so that's a quick rundown on the survey tool.
So the next thing we want to talk about is challenging installation environments, and there are quite a few. Changing environments. So probably the places that change the most is where we've got things growing, and foliage itself has a fairly high water content, so it can be difficult. All of these installs on the page, while they're surrounded by lovely green growth, or cane field in that case, are working installations. So it's not that they're bad installations. It's just that in these cases, if you have really heavy rain, you get a high water load on the leaves, then your reception strength can change, and potentially it could block out some data from that tag. Of course, once everything dries out, you'll be able to see it again. But of course, also the foliage grows, so it gets thicker and thicker around tags or meters, and so that can change the way that that particular meter will work. Because I'm certain that all councils have the ability to go along and have a chat with residents about clearing out, making a clear path to the meter. That may be something that you have to do, but it's just to be aware that things do change out of the environment, and it's not just, you know, people parking cars over the top of tags. The environment itself can change. There's a question from Paul: would the V200 then be orientated towards the receiver as opposed to directed vertically? Paul, in the instance with the V200 and the antenna there, the power gets radiated essentially in a 180 or in a semicircle, so half a circle. So you actually end up with as much power coming out to the sides as you do from an ADC, just because of the way that that works. So I'm happy to go over that in a bit more detail with you later on if you'd like. So just find my button here to go to the next slide. Why is that not doing that? Oh, no. Sorry. There. Long distances, I talked before about 88 kilometres for an HP. That's certainly not the record. I think we've had 265 kilometres, and someone will probably tell me that we've got longer than that. Of course, we don't normally design networks like that, but sometimes when you're a long way out, you need to do some extraordinary things to get reception. In this instance, you know, the higher that antenna is, the further you're going to get. This is obviously a water meter on a water tank for feed a stock tank. The higher you get that, then the better range you're going to get. Essentially, what you're doing is you're getting out of the clutter down around ground level, which is essentially, you know, foliage, buildings, fences, all of those sorts of things. You want to get up as high as possible if you're not being seen from down here. Of course, if your tag's seen perfectly down here, you don't need to worry about all this stuff. That's just to get around some issues. Underground and basements, concrete, reinforcing, all of those sorts of things, being inside a house, all of that sort of stuff will soak up some of the energy from the tag. Once again, all of these are working installations, and I think, is it that one? Maybe not. But, you know, we will often be able to get a signal out of spaces where you can't get phone reception, for instance. I was doing something the other month for a customer who had a 4G logger down in a sub-2 basement level, couldn't get a signal out of that. We put an HP tag on, like these ones here, and that signal boomed out without a problem. So it's about selecting the tag. So you can see that most of these are HPs, because we're coming out of difficult environments from inside of buildings and that sort of thing. But sometimes all you need is an ADC, or in this case an MRC on a V100. So it's, you know, there's no need to spend the extra on the HP if you can get away with an MRC. Doing those signal strengths is really important about that.
Yeah, I think the important thing to point out is like the brackets that are used on the first picture there. You want to always protect the antenna. You would never install that bracket on the top half of the tag, because that will hinder your signal. So you always want to keep the antenna protected. Yeah,
absolutely. Yeah, obviously putting metal around the antenna is going to block out your signal. So what's that not going forward? There we go. Metal obstructions. Well, this is almost as bad a metal obstruction as you can get. A big metal box. We've got a tag inside here. Now, fortunately, in this particular instance, this big metal box has got a gap down through the bottom here, so signals won't go through the metal, but will bounce down through there, and the receiver is actually quite close in that instance. So it's not that you can't get out of those sorts of things, it's just you have to select the right tag, put it in the right place, and check it before you go. So I'm guessing that somebody got inside that big metal box to do the test with the doors closed. The other difficult area is pits and heavy lids. So as you can see, if you get metal lids here, they're thick metal lids, then you need to be able to deal with that. So we've got a little bit more further on, but you can see we've got a plastic lid here, and just being able to use a V200 HT, so 25 milliwatt. But here we've got a big thick metal lid, and we've had to use an HP. Once again, the metal bracket is down around this part of the tag, not up on the antenna. Okay, so often there's a lot of muck and whatever inside pits, and I think we've got a couple of pictures of that. There we go. Aside from things to watch out for, aside from council employees who lock you inside a metal box. Did that actually happen, Siobhan? Yes, it did. Okay. Well, there we go. Poor old Joe. But they let him out because I've seen him in the office since. So mounting tags sideways, these tags are being heard, but this is not a preferred way to mount the tags. They're hard up against the metal of the pipe, and they're strapped on with the cable ties. Much better to use the ADC bracket and have that sitting vertically to keep the antenna nice and clear of all of the metal down around there.
And also probably use stainless steel cable ties in this instance, because the idea is to make the install last as long as our tags do, which is, we expect 10-year life out of these. So you want whatever the brackets used or whatever the mounting is used to last 10 years as well.
Yeah. Yeah, certainly those would look like they look like the UV resistant tags. I know some of the cheap cable ties. Some of the cheap cable ties will just fall apart within 12 months. So then you'll be going back and doing the install again, which obviously you don't want to do. Metal cable ties if you possibly can. Here we can see exactly where that's happened. Cheap cable tie, and the tags ended up just sitting down. They've actually used a bracket, which is nice, but the tags have sort of fallen down here. And in this instance, once again, while that's working, we've got the metal cable tie up around the antenna. Probably not ideal. Even if it is working, it's just not ideal to do that. Anything else to add on that, Amal?
No, not on that one.
All right. Oh, the other good thing, actually, you can see the bracket here used to hold that onto the meter. That's really good practice. So being covered in liquid, water absorbs radio waves. So when things are covered, then obviously the signal's not going to get out. So it's another good reason to keep tags pointed vertically and as high in the pit as possible, because pits will fill up with water and dirt and muck, and in this instance over here, lots of oil. I think for that one, that pit is out the front of a mechanic's workshop, and the council employee, if I'm not wrong, said, I'm not going to go near it. You guys read the meter, I'm not doing it. So I guess that's just another good OH&S reason to have automatic metering. Down here, obviously you can see that the meters can get covered in dirt, muck and water. So that's what happens when things don't get cleaned out. So there's some good installations. You can see on this one, metal cable tie, nice antenna sitting upright. The conduit over the lead here, so it makes it more resistant to cockatoos. although we've got a cockatoo of our own, but yeah, anyway, makes it more resistant to cockatoos. These ones, as we saw before, metal cable ties. The lead is nice and restrained, and a good bracket around the meter. Did you want to add anything more on that, Amal?
No, like those installs.
Okay, yeah. Any other good things to point out about them?
Yeah, the cable management. You don't want lots of cable dangling. I think you mentioned that.
Yeah. Yeah. So generally we will, if we're not using an integrated meter, obviously, generally we'll deliver a shorter cable as possible to specifically avoid those sorts of issues. So a closer look at pits. Nobody really ever wants to go into a pit, but I guess we've got to look at them. Okay, so pit lids, and you all know this this better than we do, but the pit lids need to be rated for the applicable load standard, an Australian standard for that. And the pit and the lid affect, as we said before, affect the radio environment. So the material of the pit, the material of the lid will either make it easier or harder for the signal to get out. A metal pit and lid, it's probably the worst combination you could probably have. While a little bit of concrete we can probably blast through. Concrete gets wet, makes it very difficult. But metal is just metal all the time. And the location of the tag in the pit, as you can see, this one's, and I've got some more pictures in a minute, but this one's nice and vertically orientated to keep the antenna as close to the lid as possible. And if you're thinking about the type of plastic lid that you're using, because like oils ain't oils, plastics ain't plastic. Strongly advised over metal or concrete. There's lots of reasons for that. If you drop a plastic lid on your foot, then that's not going to break your foot. But if you drop a metal lid on your foot, if you don't have steel cap boots on, then you're probably in trouble. Concrete, as I said before, it gets wet, absorbs water pretty badly, and that will affect the signal strength. So here, this is about positioning the antenna in a pit. So just starting from the left-hand side, as you can see, we've got sort of that lightsaber bubble. Here's the meter and the pipe. The lid of the pit's up the top here, and this is the tag. So that's essentially the effective area you've got, or that you have from the power of the signal. So all of this signal power. So we've got 500 milliwatts to play with. So it's a high power tag. All of that gets lost. So you only end up with that little bit here. Similarly, and it's a bit hard to do these sorts of things on a side view, but the same sort of thing happens. You end up with about 20% signal strength, less than. If you put it over to one side, then once again, that whole side of that tag you're going to lose that signal. Now, that might not be too bad if your receiver was here, because then at least the power is going up to where your receiver is. But you're better off to have it in the middle of the pit, where you get, and close to the top, where you get the majority of your power out through the pit lid. And of course, if you can put it up on top of the lid, same deal. You get a nice spread of power. And if you use the right sort of lid, because plastics ain't plastics, then you can get even better signal strength. So best practice for pits: use a radio-friendly pit and lid. Mount the tag right below the lid, close to the center as possible, and horizontal or vertical in the center. So if you have to put it onto the pipework, you don't want to put it on the lid. And there's reasons for not putting it on the lid. If your staff aren't well versed in this sort of thing, and they pop that lid off and throw it away and pull the tag out, then that's probably not a good thing. So mounting it vertically in the center there is also a good install. Best practice for pits, you can see, nice and fairly central and close to the lid. This is on the side, but once again, it is very close to the top of the lid. That's on the lid, once again off to the side, metal bracket there. This one's sideways, but pits, as I said, are often full of muck and dirt and those sorts of things. And sometimes you just don't have room to mount it vertically. Perhaps you don't want to dig down through whatever is in that pit and has been there probably for the last 30 years. So some tags get mounted in like this, but you're still up close to the top of the lid. Any comments from you there, Amal?
No.
Yep. Okay. So what happens when you can't get out of a pit? I think there's a story about that. Anyway, well, we've got ways to get around this as well. And probably one of the better ways, if you can't change the lid material, if you can't get a signal out of the pit lid itself, then we can use a road marker antenna. So with that, it's always an HP tag, and then we put an external antenna on that HP tag, and then we can mount that either on the lid itself, as you can see here, or as you can see down in this picture, down towards, we can actually mount it inside underneath the
asphalt.
Something here under the asphalt,
yeah, so
and grout it in.
The little wet patch there is actually the antenna. They've embedded the antenna in the ground and
down
then
through here.
Over
yeah. Sorry, my laser pointer's getting hidden behind the video panel. So it's there. We can hide the video panels better. Yeah. So just down through there. So sometimes the holes in the standard hole in your pit lid can be your friend. If you can get your antenna nice and close to that, sometimes that can help you out as well. But if in doubt, a remote antenna will get the signal out. The material of pit lids is important, and so for that reason, and we obviously come up against this sort of thing all the time and have for many years, we've taken on the agency for Nicor. Nicor are an American manufacturer of polymer lids, and they make what we think is the best lid we've ever seen for radio transparency. They're made of a 100% virgin hydrazone polymer. Other plastics often have fillers in there, and so those fillers actually help absorb water or block radio signals as well. So like all plastic lids, they're lightweight. We can have things in there like rebar so that you can find them if they get buried, and also for additional strength. Doesn't absorb water. They've all been tested to AS3996 Class C. So for a plastic lid, Class C is pretty good. We can do Class D with a combination metal and plastic lid. We'll be doing some more information sharing specifically on Nicor at a later date. But this is the sort of difference that you see. So this is concrete and metal lids, and this is an Nicor lid, and that just is representing range and signal strength. So the reason why it's good to get better range is that better range means less infrastructure for radio, for your radio receivers. So you'll get better coverage of the area, and better signal strength and more reliable data henceforth. Nicor also do a modular box, and it's a 4-piece box that comes apart and flat packs, so that if you've ever had to install, 300-400 or 3,000 or 4,000 pit boxes, they take up a lot of space on a truck. If you can flat pack them as these are, then we take up about 1/5 of the amount of space, maybe even less. And they're once again, the lids are tested with the box, meet Class C Australian standards without a problem. So you get cost savings for freight, they're lightweight, they're easy to assemble, they just clip together on site. So it's a very quick and easy process. And there we go, that's the end of this presentation. There is a question here from Ryan, wondering why brackets used are metal rather than plastic. So the bracket that we're talking about there is the tag bracket itself. The tag bracket doesn't go up past the antenna, so it's much better to use a metal bracket just for longevity. We do have some plastic brackets in development, but at the moment we're using the metal brackets just purely for strength and longevity. So I hope that answers your question, Ryan. So I think, does anyone have any other questions that they would like to ask? I think you can just put your hand up on your screen and Siobhan will unmute you. Right. I just saw Ryan O'Dant's question. That's a full metal pit. Yeah, full metal jacket. Very good, Ryan. Very good. Well, if there's no questions, and oh, here we go. We only talk about Elster meters. Do they work on Itron meters? So, Paul, yes, absolutely. We've tagged plenty of Itron meters. SA Water use a combination of Elster and Itron. It's really just a matter of choosing the sensor that matches that meter. We've got, I think, something like 80 brands, maybe 50 brands of meters and 80 types of meters that we have worked with. So we have the integrated Elster meter and the integrated Akiba meter, so two different brands there where we have our radio integrated inside the meter. But we've worked with all different types of meters, whether they're mechanical, whether they're you know, ABB or Siemens or Krona, Magflows, Modbus outputs, all those sorts of things. We can do all of that. We have done all of that. Okay. You can speak on the processes for rolling out large volumes of devices, QA checking and tasks. So that's a good question, Ryan, and not surprising from you. You've been involved in the industry a bit. So one of the key things is collecting the right data at the install. So our processes include capturing all of that data up front from the council in our Aqualis Water and having an integrated rollout process using the field app that captures the data of the meter, matches the tag data, captures the previous meter reading and the new meter reading if we're changing it, or the existing reading, so that you've got all that QA'd. And that's all captured live on the field app on the tablet. The geolocation is captured live at the same time. Photographs of the location of the, you know, before and afters of the meter. So all of that sort of stuff is there. The whole idea is that, you know, it's garbage in, garbage out. So if we manage the information flow during an install, then we're going to get a good quality install.
Yeah. So rollouts where Taggle does the install, where we use our preferred partners. There's also a QA step after that. So all those photos you just spoke about, they all go into Aqualis Water, and then there's a desktop audit of every photo. So to make sure that the Taggle serial matches the meter serial, matches the property ID, and so there's no bad data after that. So that's all done during our standard rollout. Yeah,
it's all included in what we do. Okay. So happy to take any other questions. We're about 40 minutes in, so.
There's a question from Ash. Does voltage current on the connected steel pipe work have any impact on the operation of the V200 meter?
So the answer to that is we haven't seen that. I don't have a specific answer to that, but I would suggest not, because it's going to travel through the metal preferentially and not up into the circuits. All the circuits are fully potted. I can get you a full answer on that, Ash, but I would suggest that no, there won't be any influence there.
Unless the only thing I can think of is maybe interference caused by it, but yeah, we need to ask Richard about that one.
Yeah, I guess we can only say we've never seen that effect. We've got 220,000 meters out at the moment, and
Yeah.
that's never come up as an effect. Yeah. Okay, so unless someone else has got another question and happy to take them, then
Hey, Steve.
Oh yes,
Can you hear me now?
I can.
Hey, I've got a question about the rollout process.
Yep.
If you had freedom of choice on how you structured the teams and you were rolling out in a typical suburban setting where the meters are at the front of the property, nice and accessible, what would a crew be structured like? Would you have one person doing their own installs and their own QA checking, or would you have two-person crews, one doing physical installs, the other doing data collection? Have you found efficiencies to be greater one way or the other?
Are we changing the meters as well, Ryan, or just putting tags on existing meters?
Either or. Curious to know for either.
So obviously, if we're changing the meter, we need a plumber, but then generally it's a plumber and a single data capturer.
Sometimes it's one data capturer amongst two plumbers.
Yeah. Yeah. I think I won't say the difference with us, but the advantage we have is that our volume rollouts are all being done with our field app. So it really cuts down on the amount of QA, on the amount of dyslexia issues and all of those sorts of things that can happen, because you have that live check. You're geolocating right where you are. The data gets loaded up straight away. We still have the desktop QA process afterwards, as Amal said, but
but there's QA built into the tablet app itself. So the tablet app looks for duplicates that already exist because it's got a connection with the actual database. So it looks for duplicates. It looks to see if that customer that we're installing for actually owns the tag serial that they're trying to install, and we can make it check for the meter serial as well. So all those checks happen at a tablet level in the field, not later on in the office. So and it warns you on the tablet if you are trying to install something that doesn't belong to you.
Yeah, I guess the other good thing about, or one of the other good things about the tablet app is it does your OH&S checks before you install the meter. So it includes essentially a health and safety check on the install first. So you've got to walk through those steps for every single install, and it captures all that data as well.
Great, thank you.
Not a problem, right?
One more from Kale. Siobhan, do you want to take this last question? Still on mute.
Sorry, quick swap of screens. So we are recording this, and I'll put it up on the website and share on LinkedIn and all the places. If anyone doesn't follow us on LinkedIn, I suggest please do. We share lots of things on there and little tidbits. Yes, I will be sharing the recordings.
Absolutely. All right, and I think if that's all, we're now 45 minutes in, and I'll thank you everybody who has attended. I hope it's been useful, and so I'll say thanks very much, and we'll close up here. If you need to ask any questions, of us, you can certainly come and approach us directly via our contact details or via Siobhan, and we'll be happy to talk to you individually. Great, thanks very much.
Bye guys.
Thanks everyone.
Au revoir.